Okay, so in today's video, we have given the function x multiplied by x minus 1 multiplied by x minus 2, so on and so forth being multiplied by x minus 1000. The question being asked is what is f prime of 0 equal to? Meaning, so when we take the derivative of the function given, what is the evaluation of the derivative at when x is equal to 0? Kind of a crazy function given. We have a monomial being multiplied by a product of binomials, but it's not too scary. The answer actually comes out very nice, in my opinion. So with that, let's actually get started. So first thing I want to do is I want to, let's define y to be equal to our given function, x times x minus 1 times x minus 2, then so on to x minus 1000. Well, in this case, let me define n to be equal to 1000, and then I'm going to change and then I'm going to replace the 1000 with n, so it's just going to be x minus n. Okay. Then we can actually rewrite this as a product series, which it's equal to the product from k is equal to 0 to n of x minus k. Okay. Now, what I want to do next is I want to take the natural log of both sides of, so it will come down to ln of y, which is equal to ln of the product series itself to n, then k is equal to 0 of x minus k. But we can actually rewrite this term as a summation series, so we can rewrite this as the sum from k is equal to 0 to n of the natural log of x minus k. It's pretty nice. And now, next step I want to do is I actually want to take the perform a logarithmic differentiation. So we're actually going to be doing, in other words, kind of like implicit differentiation for one side. And so we get, when we take the derivative of ln of y, this is simply 1 divided by y multiplied by the derivative, or dy dx, and then equal to the derivative of the summation, which is simply, the summation sign just retains, k is equal to 0, and then it's 1 over x minus k. Then I can actually multiply the y to both sides, so then we get dy dx equal to y times the summation of the same 1 over x minus k. X minus k. And then when we do that, we can substitute y for our product series right here. So this is, I'm actually going to now write this as y prime equals the summation from n to k equals 0 of 1 divided by x minus k, then multiplied by the product series, so pi from k equals 0 to n of x minus k. Okay, now I actually want to write out the series in full. So we have x minus k when we write out the product series. It's just simply the same thing as x times x minus 1, x minus 2, all the way up to x minus n. But then we write the summation is 1 over x minus 0, then plus 1 over x minus 1 plus 1 over x minus 2, plus all the way up to plus 1 divided by x minus n. So this means I can actually distribute our product series into the summation, so it can be rewritten as so, and this is going to take a while, so just give me a second. So this can be rewritten as x minus 1, x minus 2, x minus n divided by x, then plus the same thing like before, and this is divided by x minus 1, and I'm going to write out one more term before I do the plus 3 triple dots and then another plus. Okay, then plus x x minus 1, x minus 2. Okay. And now notice that the x's cancel out, the x minus 1's cancel out, the x minus 2 cancel out, and then the x minus n cancel out from both the numerator and denominator. So this means we can actually rewrite this, and this is going to require more writing. So x minus 1, x minus 2, minus n, so that's 1. And then x times x minus 2, right now x minus 3. Then the x minus 2 cancels from top and bottom, so x minus 1, x minus 3, and then plus, and then the x minus n cancel out. So this means x minus 1, x times x minus 1, x minus 2, and then x minus n minus 1. It's a preceding term. Okay, so now that we have that, this so far y prime is equal to this expression, our summation. Expand it out. So when we plug x is equal to 0 for the derivative, that means everything from here to here is going to be equal to 0, since we have x being multiplied by the products of the binomials. So everything here is going to come down to 0. So all we're left with is just evaluating 0 from here. And now we have when x is equal 0, so this is negative 1 times negative 2 times negative 3 dot 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 all the way up to negative n, and we can actually rewrite this product as negative 1 multiply, or not multiply, but raised to the n, then multiplied by n factorial. And now that we have that n is equal to 1000, so when at n equals 1000, then we just plug in negative 1 raised to the 1000 times 1000 factorial. And because the exponent's an even number, so that means this is just simply comes down to 1 multiplied by 1000 factorial. 1000 factorial. So actually, the answer comes down to 1000 factorial. So don't read that wrong as an exclamation point or excitement, like 1000. It's actually 1000 factorial. So 1000 times 999 times 998 all the way on to times 2 times 1. So we have our answer. Therefore, f prime of 0 is equal to 1000 factorial. Sweet.